Hey, Jen, thank you so much for the kind introduction. So this talk is going to be split into about two pieces. The first half is going to cover a lot of basic AI, machine learning, and LLM things, and then we're going to get pretty deep into some of the practical applications of these techniques that I've personally executed over the last 18 months. So, visual description, I am a middle-aged woman with brown hair and a ponytail. I have pretty strong bifocals, and I'm in my kitchen, which is where I'm the most comfortable, with the map of California behind me, and I'm wearing my favorite sweatshirt, which says, if you embrace diversity but ignore disability, you're doing it wrong. So let's dive into it. All right, so first up, we're going to cover some acronyms so that people without backgrounds in this technology know what the heck that I'm talking about. First of all, AI is artificial intelligence. Unless you've been living underneath a rock, you've probably heard of that one recently. ML is the abbreviation for machine learning. LLM is for large language model. Large language models are the basis for all of things like BARD and ChatGPT. We're going to be getting into those in some detail later. GPT, a lot of people don't know that it's actually an abbreviation, stands for generative pre-trained transformers. So it's the type of AI technology that was used to build that interactive framework. Gen AI, generative AI, it's the type of AI that generates content, and that content can be text, images, and video as of about a week ago. And finally, DSP stands for define, search, and predict. That has to do with the steps that a GPT application use in order to take your input and answer your questions. Okay, so question, I just dumped a whole ton of acronyms on you. How does it all work together? Well, we've got AI, which is the big overarching technological piece. Then machine learning, which is a type of AI. So what I've got on the screen here is some concentric circles that show how each of these pieces intersect. Deep learning is a type of machine learning which builds neural networks using complicated algorithms. And that's what's used to train the models. And we'll get into model training and what that consists of in a couple of slides. And then finally, LLM. So LLM is a type of deep learning, which is a type of machine learning, which is a type of AI. That's how all of those pieces intersect. And eventually, probably there will be subsets of LLMs, but right now we're using them pretty much on their own. So there are two different types of LLMs. One is with monster unlabeled data. Okay, so nothing is categorized. Nothing has been looked at by humans. It's computationally, meaning how much computer time it uses, very expensive to use an untrained model with these large unlabeled data sets. So that's, for example, why ChatGPT limits how many queries you can run under its free version, because it is computationally expensive for OpenAI to run those queries for you. Then you can get into fine-tuned models where you actually have a human go through the data, but the data is very narrow. It's on a specific topic. So if you're a pharmaceuticals company, it might just be pharmaceutical data. If you're an accessibility tester, it might just be accessibility data and UI data. So smaller sets of data, but labeled, so it's less expensive computer-wise. You don't have to have an entire room of parallel processing CPUs in order to use that data. Okay, all data starts out as unstructured, okay? So it's not labeled, it's just text. But what happens is when you label data, you're doing something called supervised learning. And with supervised learning, you have a human that's sitting there and categorizing the data. So they will look and they will say, okay, this kind of data is good data, and this kind of data is bad data. And so what it does is it builds up reference material so that the neural networks can then later determine when they have a question that they've never seen before, does this fall into this data model or does this fall into some other data model? Okay, and that's what happens. So once you've built your data models, your users are going to be putting in unknown data. And so it's going to test against one model, it's going to test against another model, and then it's going to decide if it passes or fails. Which model does it match? And that's how it decides how to answer the information that you're asking the chatbot for. Okay, so what can you do with machine learning and AI and LLMs? So first of all, LLM, large language model. So language is the key to that definition. So anything having to do with language, large language models can do it. It can do better speech to text and better text to speech. It can summarize text, which is brilliant because those JIRA tickets that you have that have like 9 months of people's comments in it. It can actually take that ticket and summarize it into 1 or 2 sentences. It can do plain language, which is good when you don't know the reading level of your audience. And it can also do tone detection. Tone detection is really helpful for people who are autistic, who might not understand the tone of the language that they're generating and how it might be perceived. And then obviously language translation, going from one language to another language in context is something that LLMs are very good at. Okay? It's very good at object identification, navigation, and wayfinding. So it can tell you what an object is. It can tell you how to navigate around the object. How far is it in front of you? How big it is. Advanced voice assistants like Siri and Alexa can use large language models. Learning and education can be customized for an individual. So if I'm doing some training, it might detect, oh, she always turns on captions and she always magnifies things. And then maybe it starts offering me that in the future automatically because it's detected that and it's training itself on how does Sherry learn things. Sherry's also much more of a visual learner. So it might present me more visual examples instead of sound-based examples. ML, AI, and LLMs are being used in healthcare. Some of that's good, some of that's not so good. So some good examples would be interpreting echocardiograms. That's something that machine learning and AI is very, very good at. It picks up things that even cardiologists miss. There's a machine learning right now that can predict, looking at an echocardiogram, what the likelihood is of a person having a heart attack in the next year with a very high percentage of accuracy. Now let's talk about some not so great implementations. United Healthcare and Humana just got sued because they were using an AI that had a 90% failure rate to determine who got what kind of rehabilitation care after they had hospital stays, mostly impacting elderly people. And then machine learning AI is also very good at monitoring activities. So it can observe data over time and make predictions and make trends. So Uber uses this a lot for trying to decide what their surge pricing is going to be and how many cars do they need on the road for a particular time period. And finally, LLMs can actually generate code. That is also both good and bad. And so when we get into the accessibility specific applications, we'll talk about that more. Okay, so now the intro is done. From here on out, we're going to be talking purely about the accessibility applications of machine learning, AI, and LLMs. So first of all, LLMs can make accessibility recommendations. And I'll provide some examples of that in a few minutes, because it has consumed all the WAI and W3C data on accessibility. It may have even consumed, and I don't know this, some of the DQ materials that are out. For example, the training PDF files for some of the IAAP certifications, which DQ offers. It can generate test plans. So you can say, I have a shopping cart, how should I test this? And it will actually generate a default comprehensive test plan for you. The more data you provide into the query, the better the results are going to be that you get back for your test plan. It can turn complicated language into plain language. We don't spend enough time focusing on this in the field of accessibility because it's not a W3C requirement yet. But the average reading level in the United States overall, generally, is 8th grade. If you know that your audience is all people with master's degrees in cybersecurity, let's say, for an example, then you can go up to 14th grade, which is the second year of college, for example. But if you don't know your audience, 8th grade is really what you should be targeting. So you can take a paragraph that's complicated and you can say, write this at an 8th grade level, and the large language model will transform that for you. It can generate consistent plain language error messages. I actually built a chat bot at VMware, where I was previously employed, that where it would ask the developer interactive questions, and then it would generate recommended error messages. That's important when you've got different language skills of your developers. You want everybody to write the same kinds of error messages the same way to make it easier for your users. LLMs can generate ACRs and VPATs. That is something that I actually implemented at VMware, and I'll talk about how we did that a little bit later. It can improve product consistency, and it can improve product and user interactions. Okay, so now let's start with ChatGPT. ChatGPT is an AI model. They call it chat because it's got a chatbot interface where you go back and forth with the large language model. And then GPT-4 is the most recent version. That's the paid version, which is more advanced. ChatGPT-3 is free with some limitations. So this is that computationally expensive LLM that we talked about at the beginning of this conversation. It's been trained on massive amounts of data, and it allows it to generate, human-like text, image, and video results based on the input that the user provides it. So what does some ChatGPT output look like? So I have a couple of screenshots here with some generic examples. And I said, how do you make adding a product into a shopping cart accessible? And ChatGPT answered with 10 recommendations, including the keyboard navigation requirements, what needed to be done to make it, the shopping cart compatible with a screen reader, how to label things, how to provide feedback to the user, adjusting text size and colors, what kinds of errors that you should be generating, what the navigation should look like, what the design and layout should look like. So one question, how do I make the shopping cart accessible? Generated a very extensive response. Now, is this response perfect? No, because it was a very broad question. And you might want to ask the question a little bit differently, like, how do you make adding a product that has a coupon code into a shopping cart accessible? Or how do you delete a product from a shopping cart in an accessible manner? So one thing to understand about LLMs is they cannot be used, the output can't be used without review. Okay, ChatGPT-4, the paid version, had a massive hallucination yesterday. And they used the term hallucination to mean that the answers were just completely made up. I mean, they almost look like lorem ipsum data on that's placeholder text on a screen. So a human has to look at this. A human has to decide what applies, what doesn't apply, how to customize it for the test environment that you're working on. And then from that, you have an implementation plan or a test plan that can be used. So generating a test plan for a shopping cart, if I was doing it, and I've done a lot of these, it probably would take me 2 hours, maybe 4 hours if I was doing it for the first time and didn't have resources that I could draw on that I'd done previously. Generating this through ChatGPT and then just applying the customizations and the changes, you can do that in like 20 or 30 minutes. And then you can take that time saving and you can use it for other things. Okay, moving on. It can generate test plans. So I've got a shorter one here that said, write a test plan to see if a modal dialog box is accessible. And it gave me a result, and you can try putting this query into ChatGPT yourself. It gave me an objective, it gave me scope, it told me what assistive technology tools to use, and it gave me numbered steps for testing keyboard navigation, focus control, visual design, messaging errors, and interaction. That's pretty good. Modal dialog boxes really don't need too much more than that in order to test. Okay, now I'm going to be talking about a plain language example. So if you lived in the US and you're above the age of, let's say, 35, you probably had to read Moby Dick when you were in high school. And everybody knows the first paragraph of Moby Dick. It's about a whale, and I have a picture of a humpback whale here in Monterey because I love going whale watching. And so the first paragraph of Moby Dick says, "Call me Ishmael. Some years ago, never mind how long precisely, having little or no money in my purse and nothing particular to interest me on shore, I thought I would sail about a little and see the watery part of the world. It is a way I have of driving off the spleen and regulating the circulation." Okay, that paragraph is kind of why Moby Dick drives people crazy, because it's very, very evocative language, but it's also language from the 1800s that's a little bit difficult to understand. So if you ask ChatGPT, if you provided that paragraph of input and you say, rate this at the 8th grade learning level, the plain language transformation is, you can call me Ishmael. A few years ago, I didn't have much money and there wasn't anything interesting for me to do on land. So I decided to go on a little sea adventure. It helped make me feel better when I was down, and it made me feel healthier. Okay? That is language that people can understand. So the use of generating plain language for large language models cannot be understated. It is really, really powerful, and it's also really, really useful. Okay, here's another example of plain language. This was actually an alert that went out to every cell phone in the United States last winter. And I'm sure the government had 20 people in a room writing the exact language of the text messages that was going to go out. And it said, "This is a test of the National Wireless Emergency Alert System. The purpose is to maintain and improve alert and warning capabilities at the federal, state, local, tribal, and territorial levels, and to evaluate the nation's public alert and warning capabilities. No action is required by the public. So there's a grade level reading score that a lot of people in the United States use, and it's called the Flesch-Kincaid. I'm going to spell that out because I don't think the interpreters know how to do it. It's Flesch, and then Kincaid is Kincaid. If you Google it, it's hyphenated. That's how you find it. It assessed that paragraph and said that it required a second level college education in order to understand that paragraph. Okay? That eliminates 60% of the United States from being able to consume that paragraph and know what it means to them. So if you ask ChatGPT to rewrite this at a 8th grade level, it can do that. How am I doing for time, Jen?
You're great. We're only 20 minutes in, so you have about 15 minutes left.
Okay, so I'll read out the after then. It says, this is a test of a nationwide emergency alert system. The goal is to make sure we can send important alerts and warnings effectively at the national, state, local, tribal, and territorial levels. We want to see how well our system works for the public. You don't need to do anything during this test. Okay, all of a sudden you have a paragraph that most of the United States can understand. Government language tends to be too complicated for the audience and difficult to understand. And so doing a plain language interpretation gives you the exact same content, but in more bite-sized chunks, more active verb tense, shorter sentences, shorter words. So for example, you might have put in language that said purchase and ask for plain language. Plain language might change that to the word buy, B-U-Y, because the words mean the same thing, but buy is a simpler word to understand than purchase. And that's part of what plain language is all about. It's simplifying the language, simplifying the verb tenses, making things consistent, and breaking up sentences into shorter chunks. Okay, so the drawbacks of ChatGPT. As I mentioned before, sometimes ChatGPT hallucinates. This literally happened yesterday. My husband said somebody at work was asking for a question about code, about error messages, and it got back poetry, which had nothing to do with the question. So they have not yet figured out why this happens. And it can happen on an individual question basis, where you ask a question and you just get a nonsense answer, or it can happen on a ChatGPT wide basis. And that's actually what happened yesterday. Was for a little short period of time, everybody who was using it was getting nonsense answers. So you have to watch out for hallucinations, and that's why you can never, ever just copy and paste and not look at it. You have to review it. You have to customize it, and then you can incorporate it into what you're working on. Second drawback is intellectual property issues. There have already been lawsuits filed by the people who hold the copyrights for the information that ChatGPT has consumed in that large unlabeled data set that we talked about at the beginning. So John Grisham, for example, is the famous lawyer author who writes law dramas. Somebody put a PDF file of one of his books online. That was a copyright violation. ChatGPT consumed it. The question is ChatGPT continuing the copyright violation? So that's all tied up in court right now. The good news is there are LLMs, there are large language models that guarantee that there are no copyright issues. You can also build your own LLM. That is possible using technology called Lambda, and Python is primarily the language that's used to program with LLMs, and also JSON. So you can avoid the intellectual property issues by building your own LLM or using an LLM that guarantees that there's no copyright violations. ChatGPT is not the only LLM on the planet. It's just the best known and the easiest to access. ChatGPT is freemium, meaning if you want, it's free, but if you want premium service, you have to pay for it. So if you're using the free version, you get 8 queries every 3 hours. If you want the more advanced version, you have to pay for it. And it's $20 a month, which, isn't outrageous, but for some people, as a continuing subscription, that comes out to $240 a year. That might end up being more than they can afford. The results don't always contain the original author's voice. So let's go back to the Moby Dick example. Okay, the plain language version, that didn't really contain Herman Melville's voice anymore because the language was simplified and it's a little bit more generic. So sometimes one of the things that you have to do when you're reviewing the ChatGPT output is put your voice back in, but without eliminating the changes that ChatGPT made to improve the language. Okay, there are ChatGPT detectors. So there are services out there that are largely being used in the academic setting that will actually consume a Word document, and it will say whether or not ChatGPT was used in any parts of that. So there are certain words that I have now picked up on. Like one of the words that ChatGPT loves to use is delve, D-E-L-V-E. That it says you can delve into something. Word that's really commonly used in generic American conversation, but it's a word that ChatGPT loves if you're not asking it for plain language. So that's what the ChatGPT detectors are doing. It understands the structure behind ChatGPT's output. It understands words and clauses that appear frequently in ChatGPT output that don't appear frequently in a normal conversation. And that's what it's using to determine whether the provided sample text was generated by ChatGPT or not. Obviously, the academia setting has a real interest in making sure that students aren't submitting all ChatGPT generated work. Because then they're not really learning anything. They're just learning how to write prompts for ChatGPT, and they're not necessarily learning the material because they're not actually authoring it. And so, and also, there are plagiarism issues if you include unmodified ChatGPT output into a document that you're submitting for a grade. So these are all drawbacks of using ChatGPT. Now I'm going to talk now about a project that I worked on, which is in order for this to work, and we did this on a local LLM, not on ChatGPT. First, we gave it access to our Jira bug database. So we would say, go look at these tickets, and we would point within the firewall to our internal bug database, and we would ask them to summarize the tickets. And then we asked them, take the ticket summaries and tell me what WCAG criteria were violated. So we have an example here that says, you delete an item from a shopping cart. The subtotal is changed, but is not announced to screen reader users. What WCAG criteria does this violate? And it actually gives a pretty good list of the affected success criteria. So it said 4.1.3 status message, 2.1.1 keyboard, 1.3.1 info and relationships, and possibly, and then it listed a couple of more. So since the VPAT templates are standardized, you can actually feed the VPAT template into your local language model. You can feed all the WCAG criteria into your local language model. You let it access your ticketing system, whether it's Jira or Bugzilla or whatever, and then it can actually generate a VPAT for you based on the open defects. Now, you have to go through and review it. You might not like the language that it generated necessarily, but it's a great starting point to getting everything that you need from the tickets that are remaining that haven't been resolved into remarks in your partially supports sections of your VPAT. Local language models can compare products. So you can give it multiple URLs within a single product and ask it to identify differences. Okay, maybe the menu organization is different. Maybe the filtering is different. You want consistency within a product. So it's important to be able to do that. You can also compare between one URL and another URL from different products, as long as both of those products are available behind the firewall to the LLM that you're inquiring about. And you can compare dialog box organization, for example. Make sure the OK button is in the right place. Make sure the cancel button is in the right place. Make sure the X close button is in the right place. That the colors are right, that the headings are right. All the things that are just exceptionally tedious to do yourself. If you're a senior accessibility tester, you do not want to be spending time doing dialog box comparisons. But it's a really necessary part of product consistency. So why not get a local language model to do it for you? Okay, so in conclusion, and then we'll have some extra time for questions because this presentation normally generates quite a few questions. AI makes mistakes, okay? It is not 100% reliable. This is not Star Trek yet. So everything has to be reviewed by a human. There are so many memes about people submitting court cases, documents to the courts with made up information in them because it didn't get reviewed by a human. Don't make that mistake. Everything has to be reviewed. A lot of companies may be looking at ChatGPT as a way of cutting accessibility costs. My thought about this is don't focus on cutting accessibility costs. Focus on getting ChatGPT to do super mundane things like creating easy test plans and summarizing defect tickets and comparing dialog box organization or table structure, for example. And then take that time savings and invest it into accessibility features that aren't getting enough attention, that can't be done by ChatGPT. So, for example, lots of people realize that voice recognition, switch testing, and usability research are all big parts of accessibility, okay? Probably 98 people out of 100 would say, we don't spend enough time on this at our company. Well, if you're not having to spend so much time writing test plans and not having to look at dialog boxes anymore, then you might have time to do the voice recognition, the switch testing, and the usability research. In the field of accessibility, you always get 10 pounds of flour and a 5-pound bag, right? And so in accessibility, you never have time to test everything that you want to test. You end up putting 5 pounds of flour in the bag, but then you still have 5 pounds on the floor. You might be able to stretch the bag a little and get a 6th pound in there, but you're still leaving 4 pounds of flour on the floor. Okay. ChatGPT will help you leave less flour on the floor. Okay. It expands the bag for you by doing mundane, repetitive things that allow you to focus on things that only a human can do. Okay. Only a human can interact with a switch. Only a human should be, doing voice recognition. Only humans can do usability research. So just shift the focus of what you're working on. And that, I believe, is the best use of large language models. I am certain you have a number of questions, probably, Jen, already in the Q&A.
We do.
I haven't been following the chat, so apologies. And I should have told you up front. I forgot. I'm sorry. I live on LinkedIn. My QR code's on the screen right now for LinkedIn. If anybody wants a copy of this presentation, just let me know. I'm always happy to give these things away as long as you reference that it came from me.
And we will be posting them on the session page as well. There was a technical difficulty with the content and they're remediating it now and they'll be posting it later. So apologies that it wasn't ready yet, but it will be out there soon. All right, are you ready for some questions?
I am ready. I am always ready for questions.
Woohoo! All right. The first one's from Nathan. Curious what you think the likelihood is that we'll reach a point where AI output no longer requires human review. We know bias is a big problem in AI. As long as bias exists in society, will that ever be possible?
So that's a really good question, and something that I have been focusing on recently about equity and AI governance models. I'm not sure we're ever going to get rid of bias in AI. And there's actually two sources of bias. There is the data bias, okay? And then there's the bias in the developers, okay? The AI developers, 90%, I believe, that are coming out of grad school right now are white and Asian men. So it's not just disability bias, it's all underrepresented groups. When facial recognition first started, my daughter was born without ears. And the first forms of facial recognition did not recognize her as a human because it was using ears as a landmark and she didn't have ears. That has since been resolved. They're using more, eyes and cheekbones and things like that. But there's always going to be bias in that area because not enough data exists online. There's not enough representation, for example. I think only 4% of people in entertainment have disabilities. And so that's not a good representation when 20% and sometimes even up to even up to 27% of the general population have disabilities. So we have to fix the data that's being consumed on the internet. That's hard, right? We don't control that. We need better representation by others so that when the LLMs consume the data, they have less biased data. And we also need to get more people into engineering programs that are programming the AIs who have the perspective of people that are members of underrepresented communities. I do not think we will fix that in the next generation. It's at least a 20-year out problem, I believe.
All right, we have another one. See here. Curious what you think. Oh, wait a second. That's not the right one. The Moby Dick example is interesting because it's suggesting that the paragraph is improved by making it simpler language. Yet the author wrote it in a way for a purpose. Sorry. Doesn't this raise concerns about the nature of art and artists' goals? Did that output really fix Moby Dick?
So I wasn't trying to fix it, and I didn't say it was improved. What I did say is it's more consumable by a broader number of people. So if an artist intends to be elitist in their language, and of course Moby Dick was 100 years before we had computers, but let's say somebody's writing Moby Dick today Do they need to write it in plain language? No. They can write it the way they want it. The question is, can somebody who can't consume it the way it was written turn it into something that they can consume? Okay, so let's take the Enchroma, ENCHROMA, color blindness glasses, for example. It's taking something that the wearer can't consume, which is red and green, and it's turning it into something that they can consume. So that's what I see the plain language examples are for. It's to reach a broader audience, and it's more of the choice of the user whether or not to do that, and not necessarily the author. And that's one of the reasons why authors are upset about ChatGPT. It's also why I chose Moby Dick as the example, because it's no longer under copyright. So Herman Melville is long since dead, and copyright doesn't apply to Moby Dick anymore. I hope that answered your question. If not, ask a variation or put it in the chat window.
Okay, this became an interesting discussion amongst the participants, and we wanted to get your view on it. Is there a way to get ChatGPT to output the Fleisch-Kincaid reading level score if you give it the text?
I actually use a site called Good Calculators for that. I haven't actually tried to see if ChatGPT can do it. I can say, write this paragraph at an 8th grade level, and it will do it. I don't ask ChatGPT what grade level is this paragraph at. If I want to know that information, I either get it from Microsoft Word, which has Fleisch-Kincaid built into it, or I go to goodcalculators.com, and there's a Fleisch-Kincaid calculator there.
Next question is from Joe. How long before remediating a non-tagged PDF is realistic with AI?
Well, that's hard even for humans to do right now. So I'm not sure that we're terribly close to doing it in AI. I think it's one of those things where AI could take a crack at it, and then the human could improve and fix it, and maybe that speeds up the human remediation. But context is super difficult to understand and build a neural network around. We can't even generate good alt text yet for pictures. We're getting better, but we're still not good at it. So I think we're still probably a ways off from it being, push a button and it's done kind of thing. But also I think we're taking baby steps towards getting there.
And this is from Angelica. Have you found any custom instructions that are particularly helpful when using ChatGPT for accessibility?
Could you explain what you mean by custom instructions?
Angelica, if you could put that in the chat, I will come back to your question and we'll go to another one so that we can have more clarification for Sherry. This is from Kathleen. Are there LLMs out there that exist to detect ChatGPT or other LLM generated content?
So it's not an LLM ratting out another LLM. It's more like a rules-based system that checks for certain things. You don't need the sophistication of an LLM to be a ChatGPT detector. I hope I'm understanding the question the way it was written. There are websites and services that claim to provide ChatGPT assistance. I have done trials of them. They are reasonably accurate, both in the positive and the negative. When it says no ChatGPT was involved, it's been largely correct. And when it says ChatGPT has been involved, it's also been largely correct there. So it gets it on both sides, which as QA engineers know, it's very important not to just get the positive right, you also have to get the negative right.
Right. Let's see here. You mentioned the computational expense of using untrained models with large unlabeled data sets. Could you elaborate on the cost-benefit analysis of investing in fine-tuning models for accessibility purposes in comparison to pre-training models? I can speak.
Okay. So the reason why computational models are expensive when they're having to build their own neural networks as opposed to having a human label the data is because it requires so much hardware to do that. And it has to keep all of those neural networks in memory. It's one of the reasons why NVIDIA, NVIDIA, NVIDIA's stock has gone up so much is because they're the people who are putting out the GPUs in order to handle that computational expense. When you're running ChatGPT, the computational expense is OpenAI's, right? They bought all that hardware. They did all that internet scraping. That's all on them. You're just doing a web interface. So it's not costing you anything except possibly the $20 a month if you're paying for the advanced subscription. If you're building something internally, then I would start with the fine-tuned model, especially because our accessibility is such a niche subject. Load in W3C. If you take the success criteria and break them down one by one and load them into your local LLM, you're talking about maybe 160 plus or minus components to the 50 different criteria in WCAG, WCAG level 2.1 AA is what I trained my internal model on. Training it on plain language is very simple. Training it on summarizing data is a little bit more complicated, but there's open source stuff out there that you can use to train your internal local language model. So if you're working on a narrow subject, let's say you're working on low histamine diets, for example, or for generating recipes, or accessibility, or crypto tax implications in the United States. Do the narrow stuff and label it, because it's going to be the human time is going to be less than the cost of buying all those computers or buying timeshare on other people's computers to do that type of work. And you don't need all that. You only need your little narrow thing.
All right, we have 1 minute left, and I want to go back to Angelica because I got some information. So the question originally was, have you found any custom instructions that are particularly helpful when using ChatGPT for accessibility? Angelica had said, let me find it back here, the customized ChatGPT option that allows you to give direction over its overall responses. And then we also said maybe prompts, possibly Joe had chimed in with that. So back to you.
I don't know of any that are focused on accessibility. Everybody and their dog has written a 99-cent ebook on Amazon about how to write custom prompts. It is a little bit like writing Google queries, except it's more like a conversation, right? You write sentences, you use small words like that and the and my and before and after, things that you wouldn't necessarily use in Google. But other than that, writing it is very similar to writing a Google query.
Right.
But that sounds like something I should write an article on. So thank you for the idea, Angelica.
I'll look forward to reading that. So we're going to close. I want to thank you so much, Sherry. You shared so much great information, and also a big thank you to our attendees. We're so glad you were here with us.